Hello बच्चों, सत श्री अकाल and namaste from my side. How are you all? This is the beginning of the excellence batch. As I told you all into the introductory video, okay, the batch launch, and after that one orientation session went on. Okay, so as I told you all, this is what we can say, this is not a one short batch on YouTube, but this is a kind of a batch in which regular classes will go on into the recorded mode. Entire chapter will be bifurcated right into small parts, and we are going to cover up from basics. We are going to move on from basics till top, right? So I want to tell you all just a single thing. First of all, thanks a lot. Many students might be commenting like I've received, okay, this is the day and today is the day, okay, happy Teachers Day, something like that. So I want to tell you all, we are nothing without you all. Okay, we are nothing without you all. If you are there, that is an right. If you are there, if your motive is there, okay, we are always in strive. Okay, we are always in a hunt of that kind of a student, those who are having right motive to do something, right? Okay, we are in Hindi it is said that जैसे भगवान को भक्तों की ज़रूरत होती है, तो भक्तों को भगवान की, then reverse phenomena is also possible like that. But here we need you. The future of the nation needs you. Somewhere, right, somewhere someone is sitting and watching this lecture. He might be some next upcoming scientist. He can be upcoming astronaut. He can be anything, right? So we are in search of a talent always. We are always in a hunt of it. So, okay, lots of things are going to come up into the lecture. It was all about what the auspicious day is all about, right? Lots of things. Generally, this lecture we are going to understand into the most easiest way, and the memes are only the possible thing. As per topic, lots of memes are going to come today, and from now onwards, especially lots of memes related to the physics and especially to the topics are going to come out. Okay, and we are going to understand through that. After that, from now onwards, we are going to start the live demonstrations of the relevant topic, right? We are going to use the simulations. Okay, some of the important simulations are available. Okay, and after that, right, through the very different way, into the very appropriate manner, we are going to understand some topics. Okay, and whatever the procedure we are following, that is for the entire batch. Whatever the procedure we are following, that is for the entire batch. Okay, so me, after studying gravitation in chapter 11 class, electrostatics, ab main nahi darta, right? Is it relatable? Yes, it is relatable. Okay, so let's start with the electrostatics, the first chapter, right, of the 12th standard, and among them, right, among the entire chapter, we're going to study the fundamentals of the electrostatics, that is electric charge. What is electric charge? What is an actual definition, right? How it is analogous to mass? What are the charging techniques? What are the properties of the charge? Okay, we are going to discuss into the very appropriate manner through lots of examples, through lots of numericals. Okay, so you have to stay till end and enjoy each and every moment of it. Before discussing on what is electric charge, we need to discuss the purpose of this chapter. Sir, I want to move on for USA. What's the purpose? Sir, I got admission in XYZ college. Sir, I have to move on for IIT. What's the purpose? Sir, career. कमानो है. It's not like that. It was just for a fun. Okay, but every chapter holds the prominent position into the syllabus of the 12th, and it is having its own purpose. Being a first lecture, we are going to feel we are going to enjoy the each and every moment. Just identify, okay, and most important procedure about this lecture, you all should have one notebook with you all. Okay, somewhere the mandatory points are going to come. I'm going to highlight all of those points. Immediately you have to pause the video and write it down into the books. Okay. From now onwards, whatever the notes you are going to make will be yours. Right? You don't need some XYZ author's book to understand. Right? This the each and every part of the content will be covered by in this batch. You have to make the notes by yourself in your language, right? And whatever the things that are going to come in front, I'm going to highlight all of those stuff, right? Okay, so notes are mandatory. Solving MCQs is mandatory, and whatever the DPPs are given, it is mandatory, right? Okay, so notes, be always have a book and pen with, right? Always have a book and with a pen with yourself, right? Okay, now see, what is the purpose of the electrostatic? What is a new thing that we are going to study? See, if I'm talking about the entire 11th, then we moved on to the mechanics, right? We moved on to the thermal physics. Okay, we moved on to the mechanics, the laws of motions, the rotational part and everything, the kinematics, dynamics, mechanics, thermal physics, fluids, everything we saw. A new part of SHM and waves we also, right, we covered it up. But the 12th chapter is something different. 12th, right, the 12th syllabus is something really different. The entire syllabus of the 12th that contains electromagnetism, right? Some part related to the electric fields and electricity, some part related to magnetism. The combination of both. See, if I'm talking about the electrostatics, right? Okay, this is what about the electrostatics and the electric current electricity part is there for first, second and third chapter. Immediately then it jumps off to the part of the magnetism. Then we are going to move on for the moving charges and magnetism, magnetic field, right? And everything we are going to see magnetism and matter. After that, the combination of both. Okay, after magnetism and matter, there is this EMI and AC. It is also the part of both, right? Okay, combinedly, right? Okay, we are going to see into that. After that, the combination of the electrostatics and the magnetism, right? They're going to come as the this one, the EM waves, and slowly we are moving on to the different field, that is optics, and after that the modern physics will come. So this is how the 12th syllabus is designed, right? This is how the 12th syllabus is designed. Okay. So it is important to understand what actual the electrostatics is all about. Okay, the word itself states that. I am going to focus on this point, right? I am going to focus on this point, the statics. It means what? We are studying something related to the stationary things. Right, we are going to study something related to some stationary. See, physics is all about, right, to study. Physics is all about to study. Now, what actual thing is going on here? We are studying related to some particle or something like that, that is stationary, and we are analyzing and we are noting our observation. That is what physics is all about. So stationary, it means what? Stationary, it means what? What particle is stationary? What object is stationary? What rigid body is stationary? Blah, 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 blah. Lots of questions are going to come up into our mind. So we are going to study the charges. Those are stationary. whatever the effects related to the charges, the stationary charges, whatever those were concepts they are coming on related to the stationary charges, what kind of the behavior the stationary charges hold, what kind of the effect that is generated into the surrounding area of these stationary charges, what happens when this kind or two same kind of these stationary charges are kept nearer, or two the unlike charges are kept nearer. What happens, what happens, what happens? Lots of questions mark are there, right? And related to each and every question mark we are having some specific concept. So here, before moving on to this chapter, it is important to understand what actual the electrostatics. Generally, students, right, used to judge the cover of the book, right? The physics, entire physics with the cover of the book, and it seems to be quite horrible. And for that purpose, they used to leave that part. No. This is what the cover of the electrostatics. From now onwards, right, whatever the concepts we are going to study, that will be related to the stationary charges, or in another sense we can say the static charges, the electric field and the effects, right? Whatever we are going to understand related to the static charges, the branch of the physics, right, that studies such a thing is electrostatics. Right? The purpose of the chapter should be clear. From now onwards, only one thing is going to come. What? From now onwards, only one thing is going to come. Yes, all of those concepts are going to come related to the stationary charges. Sir, you are wrong. There are some charges, right? There are some concepts, okay, in which charges are kept, and into the influence of any electric field they are going to move forward. Then how it can be electrostatics? It is the part of the electrostatics in which, right, into the slightly moving charges, right, the effect of the magnetic field is not considered. Okay, so please don't mind, electrostatics is all about the stationary charges, but wherever slightly the charges are moving under the effect of the, right, any external electric field, then there is a possibility for a magnetic field to be get produced. But at the beginners level, you all are at the beginners level. So at the beginners level, we are not considering the effects of the magnetic field. And this question, I've discussed it out again. We are going to discuss it to the later part of this session. Right? So this is the purpose of this chapter. Now, the chapter starts with electric charge. Chapter starts with electric charge. If I have to explain the electric charge into the very simplest form, or a very simplest explanation of the electric charge, and I must intrinsic property of matter. Right? Please don't mind, right? Thousands of books is having the, right, enormous amount of the content. We are not interested into it. Okay, please don't compare my content with any kind of the books or something like that. If I'm taking some out content from the respective books, then I'm going to display that part in front. Like that, whatever the things we are going to discuss today into the, right, from the NCERT, that will come up in front. Okay, that will come up in front. So whatever, if I'm going to take out something from the books, then it will be displayed here further. Please don't mind about it. Okay, but apart from that, whatever I'm going to deliver in front, it is with the motive, right, that physics should be kept well. It should be represented well into the most appropriate manner in front of you all. Physics is not hard. It is just not represented well in front of you all. If it is represented well in front of you all, things are gonna get changed. Electric charge, intrinsic property of the matter. Now see, this is a very first lecture, so slowly I'm going to move on. Okay. Intrinsic property of matter, analogy to the charge. I can say we are having mass, right? Intrinsic property of the matter. Charge is intrinsic property of the matter analogous to the mass. Like charge in electrostatics, we can compare to mass in mechanics. Analogy, this word you can search it out into the, okay. Electric charge, the very simplest explanation. Do you want the actual demonstration of what electric charge is? Let us take an example to understand the concept of the electric charge. Right. This is blackboard. If I'm talking about, this is the blackboard. Sir, you told us that electrostatics is effect of the static charges. Effect. Right. If you are telling that this is a charge, it is intrinsic property of the matter. It means it is present in every matter. Numbers may get differ, but it is present into the every matter. Numbers may get differed, but it is present into the every matter. So it means that while touching each and every matter, why we are not feeling any kind of effect? Question mark. Sir, you have to answer this question. Why we are, suppose if I am touching this smart board, why I am not feeling that kind of the effect? Charges are present, na? You told na it is an intrinsic property of matter. If I am touching this laptop, then why it is not happening? You told us, na, sir. It means something is getting neutralized. Something is getting neutralized, and we are going to see that in front. Okay. The explanation, the very appropriate explanation of the charge. This is a charge. You can see, right? This is the charge. You can see the red one. Okay. Suppose, let us take an example, another charge I am going to take. I am going to take the 4 charges, right? Okay. I am going to take another 2 charges. I am going to take, okay. I have taken the 8 positive charges. Similarly, with this, I am going to take 8 negative charges. See, this is a kind of the live demonstration is going on. Okay. This is the kind of the live demonstration it is going on. Right now into this system, I am having the 8 positive charges, 8 negative charges. Basically, according to the classification of the charges, we are having the 2 types. The first one, that is a positive charge. Generally, we can have an example of a proton that possesses the positive charge. The second one, that is a negative charge. We can compare it to the explanation of an electron. It possesses the negative charge. So this is a positive charge. This is right. I can say this entire is the system. Let's say this is the entire smart board, a system that contains 8 positive charges and 8 negative charges. Charge is the intrinsic property of the matter. Why? The entire smart board, it is made up of the very minute particles. And those particles are somewhere associated with the atoms, and atoms are having this kind of these charges. So this is the intrinsic property of the matter. This is the intrinsic property of the matter. Okay, now see. Okay, let's not associate all of those things. Right, this was just an explanation of the electric charge. This is what the simulation is there. Okay, in this entire syllabus, lots of simulations, lots of live demonstrations are going to come, and you're going to enjoy that part. Okay, so this was all about the electric charge. Okay, right now, okay, we are not going to explain that much part into the detail that how we can compare this charge to mass, what is an actual explanation, what is a detailed explanation of it. No, that much is enough. Now we are focusing on that same question, why I am not feeling the effect if the charge is present. What I told you all, basically we are having the two type of charges. The one that is a positive charge, we can have, right, the proton that possesses the positive charge, and negative as the electron. Positive charge is not a proton. Proton is a matter that has a positive charge. Negative charge is not electron. Electron is a matter that has the negative charge. So please mind that the students are always having into this kind of the myth. Right now, charge is everywhere. Why? If charge is everywhere, if Thor is everywhere, then why I am not feeling that kind of the effect? Right? I told you all, na? I explained you. We are having one system, right? Okay, that contains the 8 number of the positive charges, right? Okay, and 8 number of the negative charges. Here, the number of the positive charges are equivalent to the number of the negative charges. As of that reason, right, whenever we are touching somewhere, charge is intrinsic property of the matter. It means that it is present everywhere, whether it into the chargers or okay, please don't mind. Okay, please don't mind. Charge is everywhere. If I told you all now, if I'm taking the simple example of the body, okay, if I'm touching this up, then why I am not feeling the effect? Because we are going to study the effect of the stationary charges. These are the stationary charges where velocity is 0. Right? Why I am not able to understand that I am not feeling the effect, I am not feeling the presence of the charges. So the reason behind it, I am going to tell, this is an atomic neutral body. This is the atomic neutral body. In the atomic neutral body, the number of the positive charges and the number of the negative charges, right, are equal. Okay, number of the positive charges and negative charges are equal. I am not feeling that effect. Charges are everywhere. They are intrinsic property of the matter. Matter is everywhere. Why I am not feeling an effect? Right? Because sometimes, not sometimes, all of those charges, if I am touching them, all of those matters, those, right, I am touching them, if I am not feeling any kind of the presence of the charge, it doesn't mean charge are present. The charge are present, but they are into the equal numbers and they are getting neutralized. They are neutralizing themselves. And as because of that, the summarized effect that is coming out, that is neutral. So this matter appears to be atomic neutral body. Sometime it happens into the winters, right? If you have played the game, and generally into the childhood, we have experienced that. Okay, one of our friend, we used to tell him, just sit on the chair. Please don't touch your feet on the ground. Sit like this way. Okay, now behind that plastic chair, we used to strike with the cloth. Okay, we used to strike that part with the cloth. So what happens there? We always used to strike that part with the cloth. Okay, it means, right? Okay, and after some amount of the time, if we touch that body, now you feel the presence of the charge. What is an actual logic behind it? I want you all to comment beneath the video. Right? I want you all to comment beneath the video. Okay, now let's move on to the, after the charge is everywhere, to the basically 3 kind of the bodies. The first, I told you all, that is an atomic neutral body. Okay. The second one, that is positively charged body. The third one, that is negatively charged body. Okay. Atomic neutral body, positively charged body, negatively charged body. If I'm talking about the atomic neutral body, the number of the positive charges, right, is equivalent to number of the negative charges present. So here immediately I can write it at number of the negative charges equivalent to number of the positive charges. What about the positively charged body? The positively charged body contains more amount of the positive charges, right, as compared to the negative charges, right? So here number of the positive charges is greater as compared to the number of the negative charges. What about the negatively charged body? Number of the positive charges are less as compared to the, right, number of the negative charges. Okay, so here number of the positive charges are less than number of the negative charges. This is how the classification of the matter, that is charged body, in terms of electrostatics moves on. Types of bodies: atomic neutral body, positively charged body, negatively charged body. Sir, question. Charge, you told us. Charges, sir. Master, admin, master. You told us charge is present everywhere. It's okay, sir. You also stated that whenever we are touching the matter nearby, if it is an atomic neutral body, then we are not feeling the effect of a charge. How it is so possible that from atomic neutral body, the bodies are getting, right? How the bodies are getting transferring, or they are getting transformed, I'm extremely sorry, how the bodies are getting transformed from atomic neutral body, right, to positively charged body and the negatively charged body. How this variations into the number of the charges went on. We accept, sir, that this is a positively charged body, this is a negatively charged body, it's okay, but how it went on from neutral to being in positively charged? How it went on from neutral to being and negatively charged? From being neutral to positively charged, it means he donated some electrons. From being neutral to negatively charged, it means he donated, right, some positive charges. Yes or no? Okay, he donated some of those positive charges. Yes or no? Yes. How this went on? Is there any kind of the technique? Is there any concept behind it, sir? Please explain. The example of the day-to-day life, charging techniques. I'm going to give you all a very simple example in front, right? Things are gonna get easy, and that example is so relatable to the day-to-day life that I am sure that each and every student in his life, in his childhood, he or she might have, not might, I'm damn sure that they have experienced this thing. Charging techniques. Yes, they have experienced these things. I guarantee, I bet. Right. Basically, if I'm talking about the charging techniques, then we are having the three kind of. Conduction, induction, friction. If you want to remember all of these three techniques into the very appropriate manner, right, this is one of the memes. See, I told you lots of memes are going to come. Okay, through memes are the part of your day-to-day life. Always used to scroll on Instagram like this way, right? So we are going up to your level. We are with you. We are going to say in today's lecture, we are only going to cover like tomorrow. From tomorrow, we are going to charge with the Coulomb's law and everything. Today, we are only going to cover up the fundamentals, right? Monday, Tuesday, Wednesday, Thursday, 5, 6, 7, 8 September, we are having the 4 classes. right? Slowly, first of all we'll cover up the Coulomb's law, then we'll move on to the electric fields, and the electric field is because of the positive charge, one charge, two charges, n charges, and the continuous bodies, right? Okay, so friction, induction, conduction, simplest explanation. Through memes I'm going to explain, but first of all I'm going to show you all. Induction, conduction, friction. Induction, conduction, friction. Let's move on to the conduction first. You can see this meme, right? I'm not going to show. Okay, this is my studio room only. Please don't, please don't make out fun, huh? What happened here? Mom, beta, टमाटर. Son, no. Playing. Mama, beta, टमाटर. Son, no. Third time, beta, टमाटर. Son, mom, no. N number of times. Slowly, the power is getting raised. Conduction, it means that in between two bodies, physical contact is there. Okay, this is right. What is because of the lots of batteries and everything, they are present into the studio room, right? Lots of technical stuffs are there, so they are releasing the heat. As of that reason, I have to keep this ACS continuously on, right? So for that reason, the floor always used to get cold, and as of that reason, I have to walk. I am having the habit, right, to walk up, right, into the rooms with the slipper, right? I don't feel comfortable without this, right? So I'm giving two examples. So conduction, it means what? Between two, if you want to charge a specific body, then physical contact is needed, right? If you want to charge this specific body, then physical contact is needed, right? If mom is going to ठपाक लेके आता हूं मैं मम्मा, मैं लेके आता हूं, मैं टमाटर, आलू, केला सब लेके आऊंगा मम्मा, like that way, immediately you are getting charge, but for that the physical contact is needed. This is the best example of the conduction. If you want to transform the atomic neutral body to any kind of the positively or the negatively charged body, then physical contact is needed. Somewhere we are having more powerful moms. Induction, no physical contact is needed. Induction, no physical contact is needed. Mom, beta, tomato. Son, mom, no, I'm playing. Beta, tomato. Mom, no, I'm playing. Beta, tomato. Surs, right? They are getting raised. Beta, tomato. No physical contact needed. This raising of this surs, right? Immediately student will get charged. टमाटर, भिंडी, करेला सब लेके आएगा तेरा फैजल. Everything I will bring it. Don't tension. Please don't beat me. No physical contact is needed. Some DEET kind of these students need physical contact to get charged. But some of these smart students, by hearing the raising source, mama, beta, it means they are about to cross their limits, and immediately the matinee show will start, right? So without any physical contact, they understand, and immediately they rush off. Bhago, jaldi. Friction, rubbing is needed. Right, rubbing is needed. So these are the classification of the charging techniques. right? Hope so I have given you all to the best example, right? So this was just an example relatable to our day-to-day life. Now let's move on to the technical example to understand that, right? Okay, charging by induction. You can see one side, this is the system with no charge, right? Initially system has no charge, right? But when a negatively charged rod is brought nearer, right, is brought in contact with the body with no charge, the negatively charged rod is brought nearer to the uncharged sphere. Immediately the charge transfer takes place, and this uncharged body after some amount of the time is immediately getting transformed, right, to the negatively charged body. The charge gets distributed, right? Okay, this is the best live example. I'm going to show you all the demonstration also, don't get worried. Okay, I'm going to show you all the demonstration also. This is the charging technique. Physical contact between the two surfaces is in need for charge to get transfer. Yes, I'm talking about. Sir, I am having one question into the mind. You told us the charge is getting transferred, and charge is the intrinsic property of the matter, so it means matter is getting transferred. Boom! Yes, the matter is also getting transferred. Please don't mind, but we are going to discuss that into the later part of this session. Initially, the system is having no charge. After the negatively charged rod is kept in contact with the sphere, immediately the charge gets equally distributed in between these two, right? It depends on the how the charge distribution is going on, but right now at the beginner's level, at the initial level, we are saying that the charge is equally distributed. So as of that reason, with the physical contact, this body becomes negatively charged, and this is nothing else but in charging by conduction. The physical contact is needed. Chittar pauge tonu chittar. In Punjabi, you generally Punjabi moms used to say, chittar pauge tonu tomato nahi le aate, chittar pauge, like that way. Okay? Physical contact is needed. The second kind of the charging technique, that is charging by induction. No physical contact is needed. Okay, the best example of charging by induction, right? No physical contact is needed. No physical contact is needed. How? We are going to take the same example, right? See, I'm going to take one sphere, right, that contains the positive charge and the equal number of the positive charge and the equal number of the negative charge. Let's say it is having the equal number of the, right, the positive charges and the negative charges. Okay, equal number of the positive charges and the negative charges. Now immediately the negatively charged rod, right, the negatively charged is just brought nearer. No physical contact, just brought nearer. Just brought nearer. What happens? There exists, see, this is a negatively charged body. It means it is having the excess of the negatively charged particles. This side, this is an atomic neutral body. Atomic neutral body, it means that it contains the positive, the equal amount of the positive and negative charges. So when they are brought nearer, there exists the repulsive force between this negative and this negative charges. See, you can see in this visualization, when this rod is coming nearer, the negative charges are moving away. Why? Because there exists a repulsion. मम्मी बेटा मम्मी बेटा टमाटर मम्मी जा like that way. So whenever she is raising beta, there exists an immediate repulsion. So as of that you are pushing yourself behind. जा रहा हूँ. So there exists this kind of thing. Now what happens? Suppose if those negatively charged bodies, right, not bodies, the negatively charged particles as of repulsion, they gathered at the one side of the object. If they are grounded, right, if they are grounded, it means all of those negatively charged bodies or negatively charged particles are going to flow right to the earth. So finally the system is having only positive charges, right? And okay, if the system is having only positively charges, it means it is charged from atomic neutral body to having the more number of the positive charges. Here, see, it is not possible that all of those negative charges are going to flow through the, or they are going to get grounded. No, it is not possible. It is only possible that can have the maximum number of the positive charges. It can have the maximum number of the positive charges. So this is what happens, right? This is what happens. No physical contact is needed into the induction. No physical contact is needed into the induction. So first it is in conduction. So second, that is an induction. The third one, that is in friction. Two neutral bodies are rubbed together. All is well, all is well, all is well. Right. Two neutral bodies are rubbed together. Two neutral bodies are rubbed together. So what happens? One is, see now, you can see the cloth is getting rubbed with the PVC pipe. Cloth is getting rubbed with the PVC pipe. So what happens here? One is donating electrons, second one is accepting electrons. One donate charges, second charges. One donate charges, second accept charges, right? Okay, so two bodies are rubbed together. One is going to donate some charges, second is going to accept some charges. So in that case, what is going to happen, right? One that is going to donate, let's say, suppose if it is donating the negative charge, so it will be having the excess of the positive charge, so it will be positively charged bodies. Suppose if it is one is going to donate the positive charge. See, donating the positive charge, it is in a different concept of holes that we are going to study into the semiconductors. But right now, accepting the negative charge, see, donating the negative charge, it means one will be having the excess of the positive charge. So it is a positively charged. Now, the negatively charged bodies are transformed to the, they are not transferred, they are it is not transformed, they are transferred to the another body. So it means what is happened on the another side, the number of the negative charges are getting increased. So it is the negatively charged body, right? It is the negatively charged body. Okay. So like this way, two bodies are rubbed together and they are getting charged. We are going to move on through this example and we are going to understand this stuff. We are going to move on to this example and we are going to understand this stuff. After that, we are going to move forward with the concepts of the properties of the charges and some of the sums, are very basic and nice sums related to it. Right? Some of the basic, right? You can see we are having all of those neutral bodies here. See, we are having one jacket. Whenever in the warm winter, if you are touching up this jacket, and it seems like an atomic neutral. Why? Because it is having the equal number of the positive and the negative charges. This side we are having the balloon, right? Equal number of the positive and the negative charges, and this side we are having the wall. All of those three objects are atomic neutral. None of them are charged. Now see what happens. I'm going to show you all how conduction, induction and friction happens. Right? Suppose if I'm taking this balloon and rubbing with jacket. Again, let's understand this part into the detail. See, equal number of the positive charges and equal number of the negative charges. When it is brought and rubbed on this jacket, right? Okay, rubbed on this jacket, then jacket is going to, what we can say, donate all of those negatively charged particles. Now, this is a friction. This is having the more number of the positive charges, so it is a positively charged body, right? This is a more number of the negative charges, so this is a negatively charged body. That's why they are getting attracted with respect to each other. You can hear this voice. Now what happens here? Induction. When this is the negatively charged body, you can see, you can now visualize here, you can just observe here. Where, see, now this body contains the more number of the negatively charged bodies. When this is brought nearer to the atomic neutral wall, see, this negative charge are getting, see, this is induction. See, this is negatively charged body is getting attracted to the positively charged. Why? Through friction it gained. But when it is kept nearer, right, as of repulsion, if the negatively charged bodies are getting away from each other, right, then this wall, and suppose here from this, if it is grounded, then all of those negative charges are going to flow, right? Then finally at an end, through induction, right, it will have only positive charges. So this is not in with physical contact with respect to each other. No physical contact. See, see, no effect. In between two atomic neutral bodies, no effect. Suppose if it is rubbed, this happens generally when you are going to stick that balloon. That shows the presence of the electric charges, the static charges, right? That shows the presence of the static charges. Yes or no? Did you like that simulations or not? Right? Did you like all of those simulations or not? I will be waiting for all of your comments beneath the video. Right? I will be waiting for all of your comments beneath the video. Did you like all of those simulations? Yes or no? Did you like all of those simulations? Yes or no, guys? I love that voice. Sir, in all of your champions and victory batches, right, generally we are having your animations, right? You are showing the skills and tandavs with animations. Now this time what this thing came up in front. This time, right, the live demonstrations into the physics. I'm not saying this has been done first time, right, into an ad tech or an online platform. No, thousands of times and thousands of educators might have, right, proceeded through this, right, but they have carry forwarded this procedure. But it's okay, I liked it, right, I felt amazing, right, but it has been never done in the pure English mode, right? This thing never done into the pure English mode. Never done into the pure English mode. Okay, let's move again back, right? So if I'm talking about how we started, right, then we started with the concepts of the electrostatics, right, the concept of the static charges. Actually my slider is somewhere else, so here, okay, and after that we moved on to the electric charge and charges everywhere. Okay, then we moved on to the types of bodies, and then we moved on to the charging techniques, right, induction, conduction and friction. Okay, so for that reason I told you all, right, okay, induction, conduction, friction, this is the best way. And the mom's example, these two are going to be the craziest thing to remember this charging techniques, right? First induction, conduction, friction, and second mom, Meri ma. Okay, now let's move on to, without wasting the time, okay, the properties of the charge. If there is a charge, I told you all, whether it is a positive or negative, right, there always exists a property. Okay, there exists a property. What kind of the behavior the charge actually holds. Now if I'm talking about whenever it happens, right, the girls generally used to say, oh, how handsome is, how hot is. So what kind of the behavior, what kind of the property that hot body holds, right? Properties of the charge. Basically, there are three properties that we are going to discuss in front. The first one, that is additivity. The second one, that is conservation. The third one, that is a quantization. The three of the properties are having the very simple explanation and very simple meaning, and after that we are going to see some of the sums based on it. Additivity, conservation of the charge, quantization of the charge. So are you all ready? Yes or no? Let's move on to that. The best explanation of the additivity of charges, conservation of the charges, and conservation of a charge, and this one, the third one, additivity, conservation, which one, sorry, quantization, it happens. Okay, so what happens here, see, this is the snip taken on from the NCERT. NCERT is not helpful for JEE and NEET, sir. All the times whenever the paper is going to come, lots of students are going to claim to NTA. This question is not from NTA, this NCERT. This question is not from NCERT. At least, sir, NEET question paper should come from the NCERT, for especially for physics, sir. We can understand the entire biology and chemistry is from the same book, but physics, I think the physics NCERT holds no importance. This is what I believe, sir. Really, sir, I am also a student. I am a very experienced student, sir. I have failed in lots of tests, sir. I am having the personal experience. Did happen, sir. None of the question from the, if I'm attending the JEE NEET test, none of the question is going to come from NCERT. Always I feel helpless. ये NCERT बनाया क्यों रे? Okay. And this syllabus you will feel, especially the students of JEE and NEET will feel the importance of the NCERT. Don't get worried. As I told you all, physics is not what you are thinking. It is not horrible. It is just not represented well. And if it is represented well, then there are only limited faculties of it. Right? And maximum in PW. See, if a system contains the 2-point charges, if we are discarding this statement, this is a step taken from the NCERT visual. If a system contains 2-point charges Q1 and Q2, the total charge of the system is obtained simply by adding algebraically. System contains 2 charges Q1 and Q2. What is the total charge on the system? The total charge on the system is algebraic sum of the individual charges. Right. So total charge on the system is algebraic sum of the individual charges, irrespective of this nature or respective of this nature. Don't get worried. One example is also given. So this is what the additivity of the charges tells us about. The total charge, if we are having the n number of the charges, right, for n charges, we are having the total charge on the system is Q1 plus Q2 plus Q3 plus dot 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 plus Qn. This n number, among this n number of the charges, there is a possibility that there might be an equal number of the positive and negative charges, or it may differ depending on what kind of the body it is. Whether the body is having the more number of the, whether it is a positively charged or it is a negatively charged. So the total charge on the system is the algebraic sum of the individual charges. Again, we are going to come back to the point within NCERT. Right. This is a statement that is quite important. Right. This is a statement I hold. Right. Okay. Namely, charges added up like the real numbers. From this, we are going to get a new thing, that charges are scalar. And they are added up like the real numbers. Charges are scalar and they are added up like the real number. Suppose, as I told you all, if the system is having, right, the n charges, then this is how they are algebraically added like the real numbers. Charge, why this charge are scalar? It has no magnitude, no direction. See, similar to the mass. Analogous to the intrinsic property of, see, it is an intrinsic property of the matter, but analogous to the mass, it is having no direction. So it is the scalar. However, there is one difference between the mass and the charge. Mass of the body is always positive, whereas charge can be either positive and negative. See, what is the creativity, what is the uniqueness of the physics is always all about. Mass being positive, right? We have seen into the gravitations. If mass is always being in positive, then how the gravitational force between the two passes is always attractive. The same thing contradicts into the electrostatic. If I am taking the two positive charges nearer to each other, they are going to repel. But if I am going to take two masses nearer to each other, then there exists a attractive gravitational force, always attractive in nature. See, this is a kind of the difference, and this is what the creativity, the uniqueness the physics hold. Right? Proper signs have to be used while adding the charges. If it is a negative charge, then negative charges should be used. The sign should be used. The unit of the charge is coulomb. The unit of charge is the coulomb, right? So this is what the, can I name this as dissection of NCERT? From now onwards, we are going to use this word. Whenever we are going to review that part now, we are going to use dissection of NCERT. In each and every lecture, whenever we are going to understand this concept separately, we are going to, right? Okay, we are going to through scalpels. So additivity of the charges states that the total charge on the system, right, is nothing else but the algebraic sum. This is one of the examples. If the system contains Q1, Q2, Q3, then the addition is like that. Conservation of the charge, again we are going to do the dissection of the NCERT. Okay, if I'm going to explain you all through my procedure, okay, rather than that, okay, I'm going to explain you all whatever it is written into an NCERT, and that is the best stuff. It doesn't mean that I'm not aware of. Charge can't be created, nor it can be destroyed. Only it can be transferred, not even transformed. Energy can't be created, nor can be destroyed. Similarly, analogous, not similarly, analogous to that, the charge can't be created, nor it can be destroyed. This is one of the fundamental laws of the nature. Let's see, let's have a dissection of the NCERT through scalpels and understand what it is written into the conservation of the charge. Right, dissection of the NCERT. Mark my words, right? It is a very important thing. We have already hinted to the fact that when bodies are charged by rubbing, there is a transfer of electron. No new charges are, as I told you, I'll give you all example of the friction. One is donating something, one is accepting something. So something is going on. One is donating something, second is accepting something, right? So whatever the procedure that is going on is as because of the mutual understanding, right? I'm going to give you all the best example through the friction, through the joke of the husband and wife. Okay, many times I have heard this joke on an online platform. You all also might have heard this, right? Okay, in Mohalla, in one society, okay, generally they are having approximately 10 to 12 houses. So all of those time, from all of those 10 to 12 houses, always, right, they used to, all the watchmen used to hear all of those quarrels, right, of husband and wife, except one house. So one day from that house, the gentleman, it was asked to a gentleman. The entire society, the husband and wife, all the entire society are used to quarrel. But we never used to hear that voices from your house. And what is an actual reason behind it? So the boy told, we are having the mutual understanding between us. The small decisions are taken by her. Okay. And the most appropriate and the most needed decisions are taken by me. Then it was asked what kind of these small decisions. Then he said that what kind of the career path my child should follow. How, to make a house financially stable, right? Okay. How the marriages will go on, how to arrange all of those. So this kind of the small things, right? Okay, my wife is going to tackle. Then what kind of the big things you are going to do? He says, when the war of Russia and Ukraine will end, when the problem of the Kashmir, right, will end, this kind of the bigger issues I'm thinking, and in this always into the search of the solutions, right? So this kind of the mutual understanding, whenever they are two are getting rubbed, the charges are getting transferred, not transformed. It means they are neither getting destroyed and they are neither getting created. A picture of the particles of the electric charge enables to understand the idea of the conservation charge. Within this system, charge is conserved. When we rub the two bodies, right, one loses the charge, second or one loses the number of the charges and second accepts, one donates and second accepts, right? Okay, so here into the very system, very appropriate form, if I'm the total charge of the isolated system is conserved. This is what, right, the conservation charge is all about. The total charge of the isolated system is conserved. Total charge of the isolated system is conserved, right? It means, let's have an example to understand this stuff. Initially, the sphere was having zero charge, but this rod that was having that was a positively charged, it is having the 4e coulomb of charge, right? 4e coulomb, right? When they are brought in contact to each other and they are rubbed, the total charge of the system is conserved. This is what statement we done. Total charge of the isolated system is conserved. It means that if I'm talking about the initial position, the total charge on the system was 4e, right? Okay, the total charge on the system is 4e. When they are rubbed together, the rod got 2e. Okay, so it means initially the total charge on the system is 4e. Finally, the total charge on the system is 2e plus q dash. The total charge of the system is conserved. Very simple explanation, right? Initial, that is equal to final. This statement shows the conservation of charge. The charge within the system is conserved. That is 4e, that is equal to 2e plus q dash. Q dash, that is equal to 2e. The total charge of the system is conserved, and after rubbing, right, and charges got transferred from one body to another body, finally the second one is also having the plus 2e of the charge. Initially it was having 0, but final, right, it is having plus 2. This is an explanation of the conservation, right? After that we moved on to the quantization of the charge. It is a very, again this, right, visual is taken from the NCERT, right? The dissection of the NCERT we are going to do. Okay, the dissection of the NCERT we are going to do. Experimentally, it is established that all free charges are integral multiple of the fundamental charge. Charge on the body is integral multiple of the fundamental charge. N is integral multiple. E is fundamental charge. E, that is equal to 1.6 into 10 to the power minus 19 coulomb. From the quantization of the charge, one new thing we are going to get, right? In this formula, N can't be the fractional value, right? It is always the whole number. It can't be the fractional value. I can't say a body is having the 1.2 number of the charges. I can always be, it is having 2 charges, 3 charges, n number of the charges. So n can't be the fractional value, right? So what does this quantization of this charge state? That the charge on the body, the net, or you can say the charge on the body, is integral multiple of the fundamental charge, and it is described by this formula. It is described by this formula, Q is equal to N of E, right? Okay, so these were the 3 properties of the charges. Now we are going to see some of the sums based on it. First of all, I am going to discuss the example, the illustrative example 1.3 of NCERT, and after that we are going to see some different examples. See, this is a very first lecture, so it might seem that examples appear quite easy in front of you all, plus please don't mind. Whenever we will move forward, slowly we will cover NEET based example, JEE based example, lots of things we are going to cover, but we have to stay with us till end, right? How much a positive and the negative charge is there into the cup of water, right? Let us take an example. If I'm talking about the standard value, then a cup holds approximately 250 grams of water, right? The cup holds approximately 250 grams of water. Yes or no? Now, suppose if cup holds 250 gram of water, right? Then first of all, we need to calculate. See, formula we are having, if you want to calculate the charge, then we are having the formula Q is equal to N of E. But for that, the number of the charges we are in need of. What is an atomic weight? We can say 18 gram per mole, right? This is a molecular weight of the water. I'm sorry for my technical terms. Molecular weight of the water is 18 gram per mole. In this 18 gram per mole, we are having Avogadro numbers of atoms. In this, right, we are having the Avogadro number of the atoms. Then, if I'm talking about the 250 gram of water, then how much number of the atoms we are having? So, number of atoms, so that is equal to 6.023 into 10 to the power 23 into 250, right, whole divided by 18. This much amount of the atoms we are having. Now, each atom is having, right, if I'm talking about this water H2O, then each atom is having some of the positive charges and some of the negative charges, right? Okay, so total number of the atoms we got it up. Can I say this is equation number 1? Right? Can I say, right, this as the equation number 1? As per data, total 10 number of the positive and the negative charges are present inside it. 10 number of the positive and the negative charges. So here, if I'm talking about the total charge, right, as because of the presence of the positive charges, that is equal to 10 into 250, that is Ne, right? Okay, so the number of the atoms, so it means number of the charges, that is equal to 10 into 250 by 18 into 6.023 into 10 to the power 23. So this N replacing, right, we are replacing the value of this N into the equation, right? Then okay, so the Q is going to come upon as 10 into 250 whole divided by 18, right, into 6.023 into 10 to the power 23 into 1.6 into 10 to the power minus 19. This is the value of E, right? So on solving this, we are going to get the value as 1.3 into 10 to the power 7 coulomb, right? If I'm talking about the positive charge, then it is plus 1.3. If I'm talking about the value of the negative charge, then it is negative 1.3, right? See, a very simple formula, right? And how sums are asked. I'm moving aside. If you want to take a screenshot on the countdown of 5, you can. 5, 4, 3, 2, 1. 1.6 milliampere flows through the conductor if fundamental charge value is 1.6 into 10 to the power minus 19. How much number of the electrons are passing through second? The formula of the current states it is charge flowing per unit time. Current is 1.6 milliampere. It is. Can I, according to the quantization of the charge, can I replace Q as Ne? 1.6 into 10 to the power minus 3. What is the value of N that we need to calculate? 1.6 into 10 to the power minus 19. Right? 10 to the power 16 charges flows per second. 10 to the power 16 charges flows per second, right? This kind of the very easy sums are going to come. If a body has a positive charge, it means what? excess number of positive charges, right, least number of negative charges, right? What is the specific charge for any particle or any specific atom or something like that? The definition of the specific charge to mass ratio, there is, see, we are not having only three properties of the charge. There is another property which is known as charge is invariant, right? Somewhere it is associated to the specific charge, right? Charge to mass ratio, right? This thing we are going to use right into the upcoming part of the chapter. If object is positively charged, theoretically mass of the object increases or decreases. Object is positively charged, it means somewhere it is having more number of the positive charges and less number of the negative charges. More number of the positive charges, and it means somewhere he has donated the electrons or it has donated some of the negatively charged particles. And if it has donated, as charge is analogous to the mass intrinsic, if he has donated something, it means mass of the body has decreased slightly by this factor, because he has donated the negatively charged particles. Now mass of the negative charge is like this way. Suppose he have donated, mass of the electron is like this way. If he has donated 1, then 1 into this value. He has donated 2, 2 into this value. He has donated 3, 3 into this value. Right? Okay. I think we need to use the red pen. It is not visible. Right? Which of the following charge cannot be, right? Which of the following value cannot be the charged on the body? As per formula, Q is equal to N of E. Let us take this value, 4.8 into 10 to the power minus 14 is equal to N, 1.6 into 10 to the power minus 19. Here, N value is going to come upon as whole number. It is not a fraction value. Right? Similarly, not a fraction value, not a fractional value, right? Not a fractional value. This is only the object that can have the fractional value, right? So this charge is not possible. From this, the number of the charges are going to come upon as the fractional value. That is not so possible. So C is the perfect answer. The attraction is the real proof of charge being, object being charged. It is true or false. The one thing that I am going to give you all into the homework, right? And I will be waiting for, right? This is a kind of the proof that how attentive you are and how awesomely you have attended this session. Right, how awesomely you have attended this session, right? Okay, now let's move on to this. First of all, from the beginning, let's have the glimpse what we have studied. Okay, see, we started with the very fundamental thing, electrostatics. We started with the meme, relatable. We started with the electric charge, the definition of it. Charge is everywhere, types of bodies, charging techniques. Best example, induction, conduction, friction. That we have seen the dissection of NCERT, conservation of charge, quantization of charge, right? And some of the examples based on it. And one of the homework I have gave you all, right? Okay, I want the answer right of this question beneath the video. So this lecture was very fundamental. Okay, none of the hard thing we discussed. So this was just a proof for you all that how physics we are going to discuss in front of you all. How? In what way? Live demonstrations are going to come, visualizations are going to come, lots of practical application from my nearby area going to come, lots of numericals are going to come, lots of hard numericals, lots of JEE mains numericals are going to come. Okay, so this will be the complete package, and even on the regular basis. So this is what I'm going to tell you all. Take a pledge, right? We are going to attend the each and every class of the excellence batch daily. Please. This is a regular batch. We are going to walk together from this is a beginning at the end, right? I want you all to be with us. Course free of cost, each and every minor. I guarantee the minor and minute details that what we are going to discuss that might have not discussed into the else part or in the else sections or in the L, not else section, into the else blah 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 dot dot dot, right? So please stay with us. So guys, I think that's enough for today. It's time to go. This is Indrajit Singh signing off from the desk. Again, we are going to come back. See, धरती घूमना बंद करे ना करे 3:30 बजे सोमवार से गुरुवार इंद्रजीत सर आ जाएंगे 3:30. ठीक है ना? तो आ जाना. Tomorrow 3:30 p.m. I will be waiting for you all, because tomorrow we are going to start with the Coulomb's law, vector form, scalar form, and awesome examples based on it. Right? So this is Indrajit Singh, guys, signing off from the desk. Bye bye, Sat Sri Akal, and Namaste from my side, Bacha. Bye everyone. Stay safe, stay healthy. And I will be waiting for all of your comments beneath the video regarding this. Right? Okay. So this is Indrajit Singh. Sat Sri Akal. Bye. Bye everyone.